Hi, this is Professor Stugard, and in this video we're going to be discussing the concept of control flow. So our goals today are to, well, first of all, understand what is meant by control flow and what it means in the context of a computer or having some sort of computer or program make a decision. The main way that's going to happen is by using the if statement, and so we'll take a look at that. And then we'll also talk about what if we have multiple branching statements. And we'll take a look at, again, the whole kind of if family of functions that let us control the flow of our programming. So, again, what is control flow? Well, it's the technical term that we use in computer science or programming for when we want our program to make a decision. So control flow is basically just decision making. So what we want to do is try to formalize the entire decision making process for our program. So let's talk about a simple example of making a decision for, well, ourselves in real life. For example, what happens if I walk into the kitchen? So we're taking a look at what I should do if I walk into the kitchen as a flow chart. Again, you might have seen flow charts before where basically we're going to make decisions at different nodes, and depending on the decisions that we make, we're going to end up with different outcomes. So we'll start. I walk into the kitchen, and the first question I should ask is, well, am I hungry? If the answer to that is no, then, well, don't eat anything. But if I am hungry, well, that leads to another question. Am I very hungry? And if I am very hungry and I answer yes, then I should probably make an entire meal. But if I'm not very hungry, then I should only have a snack. And so the idea is that we ask yes-no questions about different characteristics. In this case, we're asking yes-no questions about the characteristics of my hunger that guide my decision about what I should choose to eat. Now, this concept of guiding decisions is really what control flow means. We answer yes or no questions that will lead us to different conclusions. Now, in programming, we don't say yes or no. In programming, we use our logicals, true and false, to make our decisions for us. So that means, well, we need to create statements that will turn out to be either true or false. So again, in this kitchen example, when I ask those questions like, am I hungry? Instead of saying yes or no, I need to answer true or false. And again, that's the most common way that we come up with true or false results in our programming language is through our comparison operators. So a quick review, our comparison operators, we have our logical comparisons, which would be the less than, the greater than, less than or equal to, greater than or equal to, the equal to. And again, when we're doing the comparison, remember it's the double equals for our comparison operator for equals. And then not equal to, which is the exclamation point and then the equal sign. And again, that exclamation point is basically our negation, saying the word not. All right. Now, again, we've used these in different contexts, so we can use these in the console just to check certain conditions. Most of the time we've used them, though, as the conditions in our filter function, where basically the filter function runs through every row, and it runs the comparison operator. And if it's true, we keep that row, and if it's false, we reject that row. And so it's actually doing that control flow for us, and it's actually doing that comparison. And again, if it evaluates to true, keep the row. If it evaluates to false, get rid of the row. Now, what we're going to use it in more commonly now, when we start building our programs and we start building our own functions, is going to be with the if statement. And the if statement is about the most fundamental statement that we actually make in our general programming. And so typically the if statement is going to follow this structure. If, and then we give some sort of condition, right? Some sort of comparison operator maybe, and we see if that condition is met. If the condition is met, if that evaluates to true, then we'll run a certain block of code. Else, meaning, if it's false, right? If else, right? Else being the other option. Else, we run a different block of code. And that's basically how we would set up our programs and our functions. So, again, the essential characteristic is that, well, we're creating a branching path in our code by using the if statement. So, when we do this, the syntax is, again, we have our condition in parentheses, But both the if and the else keywords are followed by the curly brackets, also otherwise known as braces. And those define our code blocks, or the body of code that we are writing and we want to be executed. Each of those code blocks, again, represents one of the paths in our diagram. So we can have some nested if statements that take us through the entire path. But again, the main idea here is that we have to decide which code block to run. Well, we don't decide it, the program decides which code block it should be running. So again, if I take another look at this I'm in the kitchen flowchart, right? Am I hungry? Yes, no. If I am hungry, then am I very hungry? Yes or no. The idea is that we would represent the choices in our decision tree with something like the following code. If hungry equals yes, so if I am hungry, right? If that evaluates to yes, then I'm going to store the value true in my hunger. My hunger is true. Else, my hunger, I'm going to store false. Now again, our code blocks and our comparison operator can be much different than this, right? Our comparison operator can really be anything that involves one of those operators, and our code blocks can be anything. We don't necessarily have to store true and false values, but again, I think this is a good kind of basic example to show that, well, we have statements that evaluate to true. We have sometimes it evaluates to false, and it helps us, again, kind of control what our program is doing or our function is doing. Now, sometimes though, well, there's more than one option. It's not just an if or an else. It's not just a true or a false. There's more than one option. And if we have a question that has more than two branches, we need, well, a slightly different function to use. So, for example, let's say I end up in my decision tree and I end up that I do want a snack. Well, there's lots of different snacks I could choose, right? So now I need to go through a separate decision tree. Well, if I want a salty snack, I'll choose chips. If I want a sweet snack, I'll choose a cookie. If I want a healthy snack, I'll choose an apple. And again, we can represent this with our flowchart as well, right? Once I get to the snack portion, I ask myself, well, what kind of taste am I looking for? And then each taste has its own end result. In these cases where we have multiple branches, we want to use the else if statement. And again, this can be a little bit confusing at first because if else is how we do two branches, but else if is how we do more than two branches. But as you practice and program with more of this, it just becomes kind of second nature. It's just learning the language that we talk to computers in, really. Now here's the way our else if statement would work. So again, we start with if, and we have our first condition. If the taste is salty, well, we choose our snack to be chips, right? We're going to store chips into our variable snacks. Now here's where the else if comes in. So again, the if part is the same, but now we run else if. So it's else, it's another thing that, it's not my main thing, right? I don't want a salty snack, so it's the else part. But there's more than one option left. So else if. So again, I basically combine my else statement with a new if statement. So then if the taste is sweet, well, I want a cookie. But again, that's not my only option. So else, but now I need else if the taste is salty, then, well, I want my snack to be an apple. So again, each of those, the if, and then the else if, and the else if, notice how each one of those has its own condition. All right. Now, the way the code works is that it's going to go through the code basically in order, and if it hits the first one, it says the first one is true. If your first comparison operator is true, it runs that code block and then jumps all the way to the outside, the end of the whole code block, and doesn't look at anything else. So you do want to keep that in mind when you're programming. It's usually not going to cause issues too much, but again, you do want to make sure that your first comparison operator actually is not going to have any negative effects on your other choices. And it's just one of those things to kind of keep in mind. But again, we have all of our options. Now at the very end, we have our last else statement. And again, we do have an else statement here that ends it, right? It's just the else ifs in the middle. And then we should always have some sort of end clause. And so else, right? It wasn't any of those three choices. It wasn't salty, it wasn't sweet, it wasn't healthy. We need some sort of last choice, some catch-all at the very end. And again, if it's none of those options, then you know what? My snack should be none. Don't eat a snack. I don't want salty. I don't want sweet. I don't want healthy. I can't decide what I want. Maybe I'm just bored and not really hungry. But okay, that's not really what the code would necessarily need. But that's the idea, and that's how we would write it and format it. So, can we answer these following questions? First of all, what is meant by control flow? What does it really mean? Decision making. Next up, a conditional statement must have what kind of output? All right, what kind of output am I actually getting with my conditional statements? And then lastly, we know we have the if statement. What was that branching statement? If I want to create a choice with more than two branches, if I need more than just an if and more than just an else, what would I put in between to have more options that could also have their own conditions as well? All right. Well, hopefully we can answer all those questions. Hopefully we learned something. And as always, take care of yourselves.